The space race was a competition between the United States and the Soviet Union to achieve milestones in space exploration. This rivalry was fueled by political tensions during the Cold War. Both countries sought to demonstrate their technological superiority and establish dominance in space. The space race began with the launch of the Soviet satellite Sputnik in 1957, which was the first artificial satellite to orbit the Earth. This event shocked the United States and prompted them to accelerate their own space program. The Apollo missions were a direct response to the Soviet Union's success in space. The space race context set the stage for the Apollo missions and the engineering marvels that would follow. The Apollo missions faced numerous engineering challenges that had to be overcome in order to successfully reach the moon. One of the most significant challenges was the development of the Saturn V rocket, which was the largest and most powerful rocket ever built. The Saturn V had to be capable of carrying the Apollo spacecraft and its crew into space and then propel them towards the moon. Another challenge was navigation. The Apollo spacecraft had to navigate through space and accurately calculate its trajectory to reach the moon. This required the development of advanced guidance systems and precise calculations. Once the spacecraft reached the moon, the engineering challenge shifted to the lunar landing. The Apollo lunar module had to safely land on the moon's surface and then take off again to rendezvous with the command module in lunar orbit. These engineering challenges pushed the boundaries of what was possible and required innovative solutions. The Apollo missions introduced several key innovations that revolutionized space exploration. One of these innovations was the development of the inertial guidance system. This system used accelerometers and gyroscopes to measure the spacecraft's motion and orientation in space. It allowed the Apollo spacecraft to navigate accurately without relying on external references. Another key innovation was the design of the lunar module. The lunar module was a two-part spacecraft that consisted of a descent stage and an ascent stage. The descent stage provided the propulsion and landing gear for landing on the moon, while the ascent stage allowed the astronauts to return to the command module in lunar orbit. The modular design of the lunar module was a breakthrough in spacecraft engineering and enabled the successful lunar landings of the Apollo missions. The Apollo missions had a profound impact on space exploration and left a lasting legacy. They demonstrated the capabilities of human spaceflight and showcased the technological achievements of the United States. The Apollo program also had a significant cultural impact, inspiring a generation of scientists, engineers, and astronauts. The engineering marvels of the Apollo missions paved the way for future space exploration and laid the foundation for the International Space Station and other missions. The legacy of the Apollo missions continues to inspire and motivate the pursuit of new frontiers in space. The Mars rovers have been instrumental in our exploration of the Red Planet. Each mission had specific objectives and goals. The first Mars rover mission was the Mars Pathfinder, which landed on Mars in 1997. Its primary objective was to demonstrate the feasibility of a low-cost, small-scale mission to Mars. The Mars Pathfinder carried the Sojourner rover, which was the first successful rover to operate on another planet. The next mission was the Mars Exploration rovers, Spirit and Opportunity, which landed on Mars in 2004. These rovers were designed to study the Martian surface and search for evidence of past water activity. The most recent mission is the Mars Science Laboratory, which landed on Mars in 2012. Its rover, Curiosity, is equipped with advanced scientific instruments to study the Martian environment and search for signs of habitability. Each Mars rover mission has contributed valuable data and insights into the geology, climate, and potential for life on Mars. The Mars rovers faced unique engineering challenges due to the harsh Martian environment. One of the primary challenges was the development of landing mechanisms that could safely deliver the rovers to the Martian surface. Mars has a thin atmosphere, which makes it difficult to slow down a spacecraft during descent. The rovers had to be protected during entry, descent, and landing to ensure their survival. Another challenge was designing the rovers to navigate the Martian terrain. Mars has a rocky and uneven surface, with sand dunes and steep slopes. The rovers had to be able to traverse these challenging terrains and withstand the extreme temperatures and dust storms on Mars. Overcoming these engineering challenges required innovative solutions and careful planning. The Mars rovers introduced several key innovations that revolutionized robotic exploration of other planets. One of these innovations was the development of robotic arms. The rovers were equipped with robotic arms that could manipulate and analyze rocks and soil samples. These arms allowed the rovers to perform detailed scientific investigations and collect valuable data. Another key innovation was autonomous navigation. The rovers were programmed to navigate autonomously, using onboard cameras and sensors to detect obstacles and plan their routes. This allowed the rovers to explore the Martian surface more efficiently and effectively. The rovers were also equipped with advanced scientific instruments, such as spectrometers and cameras, to study the composition and geology of Mars. These key innovations enabled the Mars rovers to conduct groundbreaking research and make significant discoveries. The Mars rovers have made numerous discoveries and continue to operate on Mars. The Mars Pathfinder mission provided the first close-up images of the Martian surface and confirmed the presence of rounded pebbles, suggesting the past existence of water. The Mars exploration rovers discovered evidence of past water activity, including the presence of ancient lakebeds and mineral deposits. They also found rocks that were altered by water, indicating a potentially habitable environment in the past. The Mars Science Laboratory, with its rover Curiosity, has made significant discoveries, including the detection of organic molecules and the confirmation of a habitable environment in the past. Ongoing missions, such as the Mars 2020 mission with the Perseverance rover, aim to further explore Mars and search for signs of past or present life. The Mars rovers have revolutionized our understanding of Mars and continue to push the boundaries of scientific exploration. The Voyager missions were launched in 1977 with the objective of exploring the outer planets of our solar system. Voyager 1 and Voyager 2 embarked on a grand tour of the solar system, visiting Jupiter, Saturn, Uranus, and Neptune. The primary objective of the Voyager missions was to study the planets and their moons, as well as the interplanetary medium. The Voyager spacecraft carried a suite of scientific instruments to measure the composition, temperature, and magnetic fields of the planets. They also captured stunning images of the planets and their moons, providing unprecedented views of these distant worlds. The Voyager missions were a testament to human ingenuity and engineering, as they pushed the limits of space exploration and provided valuable insights into the outer reaches of our solar system. The Voyager missions faced significant engineering challenges due to the long duration of their journeys and the vast distances they had to travel. The spacecraft had to be designed to withstand the harsh conditions of space for extended periods of time. They had to be equipped with reliable power systems, communication systems, and scientific instruments that could operate for decades. Another challenge was communication. The Voyager spacecraft had to transmit data back to Earth over vast distances, with signals taking hours or even days to reach their destination. This required the development of advanced communication technologies and the use of large antennas to capture weak signals. Overcoming these engineering challenges allowed the Voyager missions to successfully explore the outer planets and send back valuable data to Earth. The Voyager missions introduced several key innovations that advanced space exploration. One of these innovations was the inclusion of the Golden Record. The Golden Record was a phonograph record that contained sounds and images representing Earth and humanity. It was intended as a message to any extraterrestrial civilizations that might encounter the Voyager spacecraft in the future. Another key innovation was the development of advanced power systems. The Voyager spacecraft were powered by radioisotope thermoelectric generators, RTGs, which convert the heat generated by the decay of radioactive material into electricity. This allowed the spacecraft to operate for extended periods of time without relying on solar panels. The Voyager missions also pushed the boundaries of imaging technology. The spacecraft were equipped with cameras and other imaging instruments that captured stunning images of the planets and their moons. These key innovations enhanced the scientific value of the Voyager missions and expanded our understanding of the solar system. The Voyager spacecraft are still operational and continue to explore the outer reaches of our solar system. Voyager 1 is currently the farthest human-made object from Earth, having crossed into interstellar space in 2012. Voyager 2 is also on its way to interstellar space and is expected to cross the boundary within the next few years. The Voyager spacecraft are still transmitting data back to Earth, providing valuable insights into the interstellar medium and the boundary between our solar system and the rest of the galaxy. The Voyager missions have become iconic symbols of human exploration and have inspired awe and wonder about the vastness of the universe. They serve as a reminder of our capacity for discovery and our desire to explore the unknown.